Good morning, students. So, we have finished some of the topics of metals and non-metals, and only two topics are left in that chapter, that is corrosion and rusting. So today we are going to discuss about corrosion and rusting. So let's see this picture. Look at this picture. What you're observing in this picture. You can see that the iron nails. In the first picture you can see iron nails and some of the metals, alloy of irons are present in different pictures, and they are coated brown powdered on the surface. So what is this process? So you can see, just open your book and see the topic corrosion. So it is the process of deterioration of materials as a result of chemical or other reactions, right? So one line is written in there in your book that rusting, it is a type of corrosion. It is a part of corrosion, and it is a chemical process which results in the formation of red coating on the surface of metals. So generally we use this term rust or rusting for irons and its alloys. So rusting can affect only iron and its alloys. So first of all, let's discuss what is the difference between rust and corrosion. Corrosion means what? It is the process of deterioration of materials as a result of chemical or other reaction. And what about rust? Rusting is a part of corrosion and is a chemical process which results in the formation of red coating on the surface of metals. Generally we use for iron. You can see the reddish brown materials on the surface of iron when exposed to air or oxygen. Corrosion can occur on different surfaces such as skin, wood, metals, etc. Okay, but rusting usually occurs on surfaces of iron and its alloys. Then corrosion can occur when the substance is exposed to air or some chemicals. What about rusting? Rusting mainly occurs when a metal is exposed to air and moisture. Corrosion results in the formation of the oxides of metals or salts. You will learn in the higher classes, which you should know about it. But only you know that this brown material is what? When rusting occurs, this reddish brown surfaces coating is formed on the surface of iron. So what is this? This is the iron oxide. So iron oxide is formed when rusting takes place. You can see in the book the formula of iron oxide is given. What is it? Fe2O3.XH2O, right? That is iron oxide. Corrosion can occur in materials like polymers and ceramics, and this type is known as degradation. But rusting, it can affect only iron and its alloys. So this is the difference between corrosion and rusting. So what is rust? Rust is a reddish brown solid substance that forms on the surface of metal. And by metal, what we are denoting? Iron or its alloys. Now you can see that formation of brown powdery material on the surface of iron is the presence of moist air, and we call it rusting of iron. Rust mainly consists of hydrated ferric oxide. Just now I gave you example. Its formula Fe2O3.XH2. Now we are going to learn about what factors that affects the rate of corrosion. So you understood about I think you can explain or difference. You can give the difference between rusting and corrosion. Now let's discuss about the factors which affects the rate of corrosion. So the first factor is electropositive nature of metals. You can see the electrochemical series. This is the series, and we arrange these metals on decreasing tendency to lose electrons. Means the metals which we have placed above is the more electropositive in nature. So you can see that these metals means more electropositive metals means the metals which are placed above on the top of this series are more reactive. Therefore, more electropositive metals get corroded faster. For example, you can see iron. Here iron is not there. So you see this series, you can see that iron is there. So it corroded faster than silver. Silver is in the bottom of this series. So this is the reactivity series of metals. The more electropositive metals which are placed on the top of this series get corroded faster. So now I think you can understand that iron get corroded faster than silver because iron is more electropositive than silver. Now the second factor is purity of metals. Pure metals do not corrode. Means a pure metal is more corrosion resistant than an impure metal. So if you add impurities to metal, what happens? The rate and extent of corrosion increases with the amount of impurities present. So if you add impurities to any pure metal, the rate and extent of corrosion increases. That is what written in your book. The presence of other metals as impurity tend to increase the rate of corrosion. Now third point is what? Third factor is presence of reactive gases in the air. So gases such as oxides of sulfur, oxides of nitrogen and carbon dioxide in the presence of moisture. Moisture means presence of water. No, in the air. So presence of moisture produce acids and accelerate the rate of corrosion. It means it will increase the rate of corrosion. Fourth one, presence of electrolytes in water. Now what are these electrolytes? Electrolytes means in the presence of electricity, the compound breaks down. Like what example is given in your book? The presence of electrolytes such as sodium chloride in water. So if you add sodium chloride in water and one setup is there, you will learn in higher class, one setup is there, and if you pass electricity to that water, what happens? This chemical compound, that is sodium chloride, it will break down into ions, that is Na plus and Cl minus. So this is electrolytes. It breaks down into ions in the presence of electricity. So it increases the rate of corrosion. What I am telling you is the presence of these electrolytes increases the rate of corrosion. For example, iron corrodes faster in seawater than in distilled water. Why? Because in seawater, sodium chloride is present. You know that in seawater is salty in nature, and salt is what? Sodium chloride. So, seawater contains many dissolved electrolytes. See this one? Nature of the corroding environment. Temperature. So, corrosion generally increases with rise in temperature of environment. What is written there in the book? A rise in temperature within a reasonable limit increases the rate of corrosion. Means if you increasing the temperature, if there is a rise in temperature, then the rate of corrosion also increases. Okay. And you can see the other things which is responsible for the corrosion. Just now we have discussed also humidity, And what? Humidity means what? The presence of moisture in the atmosphere. Just now we have studied this one. And impurities. We have studied that carbon dioxide and oxides of sulfur, oxides of nitrogen, these are responsible for corrosion. Fourth point you leave, influence of pH. Now let's discuss that how can we prevent this corrosion, or how can you prevent this rusting. So some common methods which we are used for prevention of rusting of iron, which are we are going to discuss. Let's discuss this one. So the first prevention which we are going to prevent this rusting is by alloying. Okay, so alloying means what? So iron can be prevented from corrosion by alloying iron with chromium and nickel. What we are going to do? We are going to add this iron with nickel and chromium. So stainless steel. See, in stainless steel, iron is present 74% and 18% chromium and 8% nickel is present. It is corrosion resistant and used for making cutlery, knives and domestic utensils. So how we can prevent this corrosion or rusting? By alloying. Okay. Now how we can do? We can coat the surface of iron. So by protective coatings, if you want to protect the iron from moisture, to just be assured that the rust do not form on the surface of iron, you have to coat the surface. How? How you are going to coat the surface? So you see the book, rusting of iron can be prevented by coating the iron surface with oil, grease, paint and varnish. Okay, so you have to coat the surface of iron. Rusting of iron can be prevented by keeping the metal or any iron object such that it does not come in direct contact with moist air. As you know that if it comes in the contact of moist air, then the rusting forms. That is why what we do, we just put a layer of, or we just put a surface, we coat the surface with this coatings, with this what? With the oil, grease, paint and varnish. You see the following things which I'm going to show you in the slides, that the coatings, you can see that how the coating done. This like this coating done. Two topic is left, but how you're going to prevent this rusting is by electroplating iron with corrosion resistant metals. Now what are these corrosion resistant metals? Metals like nickel, chromium do not corrode. So that is why what we are going to do is nickel and chromium can be electroplated on iron. So if you coat iron by nickel and chromium, it gives shine also and have very decorative finish also. So most of the bathroom fittings, example taps, cycle parts, car bumper, door handles, etc. are chrome plated. So that is why we electroplate iron with corrosion resistant metals. Now this the last one is by galvanization of iron. So you can see iron can be protected from corrosion coating it with a thin layer of zinc. Now this process, when we use zinc for coating the iron, is called galvanization. So the process of depositing a thin layer of zinc on iron is called galvanization. The iron coated with a thin layer of zinc is called galvanized iron, or simply as GI. You see this one, zinc is more electropositive than iron. So as long as zinc is there on any part of the galvanized iron, iron does not corrode. The galvanized iron is used for making roof sheets, water tanks, buckets, etc. So this is very important topic. You learn this topic, galvanization of iron, as this is the very useful process. Galvanization is done by either of the following methods. How? By spraying molten zinc on the iron surface, or by dipping the iron sheet or object into molten zinc. The protection of iron surface from rusting by galvanization can be explained let's explain this one. Now let's discuss some of the activity which is given in your book. Now to test the basic nature of rust using litmus paper. How you will test that whether this rust which is formed on the surface of iron is acidic or basic. So how you are going to do is, see, the procedure is given. You have to take the small amount of rust from any iron surface. Suppose if you place the iron, you can see that in your surroundings one iron, you just keep one iron nails on the moisture, and after a few, let's say 1 week or 2 weeks, you can see the surface of iron is, this one layer is formed, that is reddish brown layer is formed. Now you take those reddish brown substances from the iron surface, and what you have to do, you just take a small amount of that rust and add 2 to 3 ml of distilled water in the test tube to cover the rust. Okay. Now shake it for few minutes. Allow the rust particles to settle down. Okay. Now to the upper layer of water, add 2 to 3 drops of litmus, red litmus. Observe the color change. Now you can see that the color of the supernatant water turns blue. This confirms basic nature of rust. Remember that litmus paper test is why we do this litmus paper test, to know whether the substances or whether the liquid is acid, base or basic. Okay, acidic or basic. When acidic substance is there, then it converts blue litmus to red, and when basic medium is there, then it turns red litmus to blue. So if you add 2 to 3 drops of red litmus, it turns to blue. That means it confirms the basic nature of the rust. The next activity, to test the basic nature of green deposit on the surface of articles made of copper. Now the procedure is given. You see, scratch the green deposit on the surface of any article made of copper. Okay, you have to just collect the green deposit on the surface of copper, from the surface of copper, and transfer it to a test tube. Add, again the process is same. You have to add 2 to 3 ml of distilled water into the test tube. Then you have to shake it well and allow the particles to settle down. Then again you have to add 2 to 3 drops of red litmus. You will observe that this red litmus water changes to blue. This shows that the green deposit is basic in character. Basic character, okay? So the green deposit on any copper article is basic in character. Now I think you understood that this rust is basic in nature, and the green deposit on the surface of copper is also basic in nature. You can explain it also. In the next class, we are going to learn about some of the uses of metals, what are metalloids, and few topics on, or we will discuss about the exercises questions also. Till then, you study well and just revise the things which we have discussed today. Thank you.